The idea of using the forces released upon discharge of a weapon in order to cycle that weapon dates from the 1880s. You have been exposed to some of the major designers, such as Maxim and Browning, and to one of the two basic systems, recoil operation. Using these ideas in the infantryman's rifle was either beyond design capability or entailed a heavier weapon than most nations were willing to tolerate. Consequently, on the eve of World War II, all nations but one were equipped with basically the same rifle they had used to fight World War I. Like this British Lee Enfield, or this German 98K, there was basically no change. They were bolt-action magazine rifles that were loaded using stripper clips. I said this was true in all nations but one. That one was the United States. Development of a semi-automatic rifle had been receiving attention in the United States since World War I. The Browning automatic rifle was originally intended as an individual's weapon. After the war, Colonel Thompson, the inventor of the Thompson submachine gun, also fielded a design for a semi-automatic rifle. His design was complicated, had a very long receiver, was not very robust, and not really satisfactory for an individual semi-automatic rifle. Pedersen, the designer of the Pedersen device of World War I fame, also designed a semi-automatic rifle. He used the toggle action very similar to the Luger pistol for his rifle. Though much closer to what the Army was looking for, the Pedersen was, for a number of reasons, also not satisfactory. John Garand, a designer at Springfield Armory, stepped into this arena in the early 1930s. By 1936, he had combined a few ideas of his own with some basic ideas from Pedersen and with the Browning gas operation system. The result was a rifle that, even though the Army designated it the M1, would forever be known as the Garand. The rifle used a gas operation system. Here's how it works. After the powder begins to burn, it generates gas at extremely high pressure and propels the bullet down the barrel. As the base of the bullet passes a gas port, a small amount of gas exits the port. This gas goes into a cylinder mounted underneath the barrel, where it further expands, pressing on a piston which rides in the cylinder. This piston is machined onto the end of the operating rod. The operating rod's other end has a cam follower slot cut in it, and this fits over a corresponding cam projection on the side of the bolt. The first fraction of an inch of movement of the operating rod allows for the time it takes for the bullet to exit the muzzle and gas pressure in the barrel to drop. The cam follower then strikes the cam at an angle, driving the cam up and unlocking the bolt. It then carries the bolt all the way to the rear, which extracts and ejects the old cartridge case. At this point, the energy in the operating rod has been spent in opening the bolt and compressing the operating rod spring. The spring now takes over, driving the bolt and the operating rod forward. The bolt picks up the next cartridge, feeds it into the chamber, and as the cam follower pushes the cam downwards, the bolt locks and the rifle is ready to fire again. This entire operation takes about 1/10 of a second. The Garand feeds from an 8-round N-block clip. It is descended from the Mannlicher N-block clip of the 1880s. In the Garand, the N-block clip is staggered double column, but still works exactly as Mannlicher intended. The rifle provides the magazine follower and follower spring, which pushes the cartridges upward so that the bolt can get to them. The N-block clip provides the feed lips, which hold the cartridges in alignment so that the bolt can push them into the chamber. After firing the last shot, the weapon begins to cycle normally. As the last cartridge is ejected, the magazine follower also ejects the now empty N-block clip. The follower rises to the limit of its travel, tripping a lever and locking the bolt to the rear. The soldier then takes his next 8-round N-block clip and presses it down into the rifle from above. When the clip locks into position, the bolt is released, chambering the first cartridge, and the rifle is now ready to fire again. This weapon obviously has some great advantages over a bolt-action rifle. Let's take a look at the Garand firing against a bolt action. The bolt will have 2 targets each at 80, 185, and 330 yards, while the Garand will have 3 targets each at those ranges. The winner of the race will fire on a stationary target at 680 yards. Perhaps that wasn't very suspenseful. On the chart, it looks like this. The combat range is exactly the same. This is because both the bolt action and the M1 Garand fire a full power rifle cartridge. The volume of fire for the Garand is quite obviously greater by more than a factor of 2. But the differences between the 2 rifles are a good bit more than what you see. It is the placing of the face and hand back on the stock, what some people call a stock weld, and reacquiring the sight picture that takes the time with the bolt action. In fact, it takes more time than the actual working of the bolt itself. The great advantage of the M1 Garand is that for the 2nd through the 8th shot, you do not have to do this. Reacquisition of the sight picture is extremely simple and fast. This is what gives the M1 Garand its higher volume of fire. Any fool can fan his finger inside the trigger guard and rip out 8 rounds in a couple of seconds. This is not effective fire. When we say 32 rounds a minute for the Garand, we mean a well-trained shooter using a sling to help stabilize the weapon in recoil and using a stable position, prone or sitting, and putting every bullet where he wants it to go. At the longer ranges, the M1 Garand is just as accurate as any bolt-action rifle. At first glance, the Garand's aperture sight does not appear to be adjustable for range. This is not true. The elevation knob on the Garand rear sight serves double duty as a ballistic range drum. After the weapon is zeroed for the individual shooter, the drum is loosened and re-indexed so that the battle sight arrow is pointing to the 0 mark. Whenever the shooter wants to fire beyond his battle sight range, he estimates the range to the target and turns the elevation knob until the range, as printed on it, is lined up beside the 0 mark. The sights are now adjusted for that range, and the shooter can fire. The M1 Garand was certainly the best general-purpose battle rifle used in World War II. Given the scope of World War II, it is difficult to isolate an incident in which the Garand's superiority over a bolt action is clearly demonstrated. We originally intended that every rifleman be armed with an M1 Garand. This gave our squads a much higher volume of fire. After-action reports from numerous small unit leaders consistently cite this increased volume of fire as a major factor. There were, of course, some places where the M1 Garand probably should not have been issued and used. In this jungle, for example, a submachine gun might be better. In most areas, particularly in North Africa and throughout Europe, the Garand was just the ticket. It was, as General George S. Patton said, the greatest battle implement ever devised.